Hey everyone, so welcome to my channel Mad Algos. So today we are going to discuss what is consistent hashing, right? So consistent hashing, why we will see like why actually we need consistent hashing, and there may be like other hashing algorithms like linear hashing. Why actually we are not going to use linear hashing? What are the problems that we have in linear hashing, which will be sorted out during the consistent hashing? And in which kind of system is it, like for a smaller system where we have only few set of servers, do we really need to have a consistent hashing? And exactly we'll see like for each what are the pros and cons of linear hashing, consistent hashing. And yeah, let's go and deep dive into it, what exactly is consistent hashing. So in large system, we may need to distribute data into multiple servers. So yes, because in one server you cannot put all the data. It may be terabytes and petabytes of data. So certainly you'll have to distribute the data into multiple servers. So and servers may be cache servers. It can be any kind of servers. As a part of scaling, we may include cache servers for scaling the cache. We may add data servers for scaling our data store, and maybe application server for scaling in the application layer. So at some point of time, we may need to remove a server. Let's say the server is not healthy. Then we'll have to certainly have to remove that servers, and what is the impact it is going to create in our network. For distributing data, we need a mapping to hit the right server. Yes, so exactly. So when we are having a lot of servers and we have put data in a particular server, let's say we have 10 servers from 1 to 10, and we have put the data in the fifth server with a particular key. So we have to know during the runtime, okay, there's a read operation for this particular key, which server to look up for. So that's how and the easiest method is a linear hashing. So let's see like what actually linear hashing is, then actually we'll try to see the consistent hashing as well, because there are a lot of problems with linear hashing. So this is how actually we can see as a linear hashing. It's the picture I have drawn is exactly like kind of hash table, but over here all the this table, this is not kind of a just a simple data structure. These all are representing a server, like 0 1 2 3 4 5. There are 6 servers, and for timing, okay, let's assume there are only like few keys stored about these servers. So server 0 is having two keys, k1 and k2. For server 1, k7, server 2, k3 and k6, and similarly for all other servers. Now let's say there is this user, okay, which coming and want to store the key k8. Okay, what it does is it passes through some kind of a hashing function. Let's say this hashing function is giving you a value of 11, right? Now as we have 7 servers, we'll have to map the data into out of these servers only. So we are taking a modulus of 7, which is returning 4. Okay, fine. So what we are doing is we are writing into this bucket 4, right? Similarly for k11, we are passing into the function hash function, and we're getting, let's say, 19, and we are taking a modulo of 7, so we are getting a 5. So what we are doing is we are writing into this fifth bucket, or like the server number 5. Now let's see, these are like perfectly fine. Okay, whenever there's a read also, okay, this guy is calling a read. What this guy will be doing is it will again be passing within the same hash function. A hash function will return 11, and you are doing a percent of 7, you are again going to get 4. So during the read also it's hitting the right server. So there is no problem at all, right? So meaning like we are able to write the data into the right bucket, and also we are able to fetch the data. There is no problem at all. But when actually the problem will arise, if something we are going to add and we are going to remove some of the servers, let's see how exactly it is going to create some kind of a problem. Let's say we are adding a new server, server number 7. Now the total number of servers that we had earlier was 7. Now over here it is 0 to 7, so we have server 8 servers, right? So now for this guy has already written some of the keys that we seen already. So now let's say this guy wants to fetch the k8 Okay, so this hash function is still the same. It is returning the value 11 for key 8, and instead of this %7, now it will take modulus with 8. Why is that? Because we have total number of servers now 8. Now it is going to give you a value 3, so it is now pointing to this point, but your value is already written in server number 4. So this is actually a travel. So what is this? Data invalidation is happening. What is data invalidation? Is when actually you have stored a data in a particular server, but when you are trying to fetch, you are hitting some different server, meaning that all the data has to be copied to the new location so that we can avoid data invalidation. So with this, actually this entire, if you'll see that all the data got invalidated, because this entire, the modulus operation that we were taking earlier with 7, now we are taking with 8. So that is why all the data will get invalidated. So this is not a right approach. So let's see how exactly we can avoid this, which will actually create some kind of a scenario that we are trying to minimize the amount of data getting invalidated. So there comes so a similar problem when we are actually removing a server. Let's say server number 3 is dead. Okay, server number 3 is dead. Now again this guy is trying to fetch out key 8. It is getting the same value 11. Now earlier there were 7 servers, now there are 6 servers. When there are 6 servers, we are taking a modulus with 6 and we are getting a value of 5. So it will try to fetch the value at server number 5, but the value is there, not there in server number 5, right? So that is how exactly the problem it creates. Either add or remove, a lot of data gets invalidated. You can avoid this if you want some kind of outage for a long time and you are copying that entire data. That perfectly works. But for a huge system, it's not possible. And even though it is possible, there is a huge outage and availability will go down. Okay, then what is the solution? Let's say this is a kind of a architecture we are going to check whether this is going to work. This is like we are going to put the servers in a kind of ring. What is that ring? So in this ring, instead of the points that we had for each servers, we are going to have like a lot more points. These are the virtual points. Let's say in this server there are like around maybe like 200 points, and we have these servers. We have these 6 servers out there: S1, S2, S3, S4, S5 and S6. These servers are over here. Now how exactly we are going to check our data for any kind of read and write? So this user firing any kind of a, let's say, write operation, so it will maybe like passing through some kind of a hash function. Then in that case, what exactly, if it is landing into this point, what it will check is the nearest server in the clockwise direction. So it is moving clockwise direction, and wherever it is landing, it will check in the clockwise direction, which is the nearest server. So it is now writing into S6. Similarly for read also, for the same key, it may land in this and it will go clockwise direction and it will try to find out the data over here. Similarly, if he wants to, like for some other key, it may land over here and then it will check for the nearest server in the clockwise direction, which is the server number S2. Now, so this is a ring structure. What is the benefit that we are going to get over here? Let's see, like less data invalidation and adding a new server is easy. Why is that? Let's see, like why exactly we think that there will be less data invalidation. Let's see through this, like exactly. Let's see like how exactly we can say like less data getting invalidated. Okay, so now we have this ring, right? So we have, let's say, this server, this server, this server, this server, and this server, and we have like multiple more points out there. We have a lot more points. Now a user is writing, let's say this guy over here is writing a data. It may, like for a particular key, it is trying, it is hitting this server. Okay, it writes the data into this particular server. Okay, let's say this is S1, this is S2, this is S3, this is S4, and this is S5. Now, what we said is we want to add a new server. In that case, what is going to happen, right? So what is going to happen? What we are doing is we are, let's say, let's say we are adding a server over here, a new server, which is server number S6. Now, what was happening earlier, the data in this region, whatever was, they were getting served by this server, right? Now what will happen is data in this region will be served by this server, right? But all these servers are still like serving the data whatever were there, right? This entire is still getting served by this server, this entire getting served by this server still, and this point also by this server, and similarly for this also this server. So if we'll see, by adding a new server, we are seeing the data invalidation happens only for this server, meaning so that is how exactly we avoided a lot of data invalidation of all the servers. Adding a new server is only creating problem at this point. So when we want to put this server, what we are going to do is whatever the data that over here is there, that is meant to be served by this guy, we are going to copy this data, copy, and then we just put the server over here in the ring. So in the next time, whenever a user is making a request at this point, it will be served by this server. So that's how actually adding a server is really easy when we are talking about ring structure. But now let's see what will happen if we want to remove a server. So that may create some kind of a problem. What are that? Let's see. A big problem is first is a load imbalance when a server dies. We'll see like why actually we see a load imbalance, and this may lead to a cascading failure. Let's say we have this ring structure, everything is working fine. Now let's say this section is served by this guy, okay, and this section is getting served by this guy, like S5, right? Now let's say this guy is dead, right? For this server, now the problem is when this this entire load will now be going to this guy. So if whatever the load this guy was handling, let's say all are evenly distributed, if it was handling X load, now it is going to handle is a 2X load, right? So now it may happen that this is not like having that much of capacity to serve this much of traffic. So in that case, what will happen is this may also die. So now what is happening is for this guy, it's a trouble. Like it was serving this guy only. Now the two sections which are over here will be routed to this guy. Now what will happen is for this guy, it's not X, it is now 3X. So this will also die. Similarly for this guy, it will come as a 4X, this will die, and similarly for this is 5X and this will die. So eventually like entire system is down. This is called a cascading failure. So this is a problem when a server dies. Then what is the solution over here? So consistent hashing, it is a special type of hashing which ensures minimal remapping of keys, easy to remove or add new servers. We can use multiple hash to avoid load imbalance in case of a server failure. Let's see how exactly we are going to achieve this consistent hashing, and adding a new server and removing would be easy. So this is how again we are going to have a ring kind of a structure. Over here, let's say we are adding any kind of a server. So when we saw this ring kind of structure, right? So now what we defined earlier is for each server there is a 1 point, right? So we had these lot of points over there in this ring, right? Now let's say for each server we had only 1 point, right? Why? Because we were using only one hash function and we were passing a key and that was writing to a particular server, right? Now what we are going to do is we are going to have multiple hash functions like h1 and h2 and maybe like h3, right? So what will happen is these all hash functions will give different points to me. So what we are going to do is we are going to create virtual points for the same server. Like for server S1, it is over here. This is also point which defines the server S1. It is not the real server, but it's a virtual point. And this is again S1. These all three are S1. So what we are going to do is the write, whenever we are writing to a server and we are going to read, let's say this guy is firing a read operation, so again like it will be passed through these three hash functions to find out the value where it is. So why actually we are doing so is, let's see like why exactly we are going to do so. Let's introduce some more servers over here. Let's say this is S2, and over here maybe like there is a S2, and maybe like there is a one more. Let's introduce this as S2. Let's say over here maybe like S2, and some more like, okay, S3 we are putting, let's say over here it is S3, and maybe this is S3, and let's say maybe this is S3, right? Okay, and maybe this is S4, and let's say one more maybe somewhere S4 is over here, and let's say one more S4 over here. Now in these regions like there are a lot of points over here. So now what will happen is, let's say we saw like there was a problem in ring architecture to remove any server. Now let's say any server like, okay, dies. So over here we see, let's say S1 is dead, S1, so this will be removed from this entire ring. S1 goes over here, right? Now earlier what was happening is, if some server was dying, that entire traffic for that was routing it to another server, like only one server, right? So over here if you'll see like S1, this section which was served by S1, now this will be routed to S2 over here, right? Now in this is if you'll see, this which was getting routed to S1 is now routed to S4, right? So this is like, you know, getting evenly distributed, right? Now similarly S1 is dead over here, so this was which was getting routed to S1 is now getting routed to S3. So over here like what we see is the entire load of S1 is not going to one server, rather it got distributed to S3, S4, and over here is S2, like S2, S3 and S4. So it got evenly distributed. So if we have like enough capacity at least to handle like some kind of a X by 3 load, so we are good to go. So earlier which was like entirely putting the load of one server to another server, so that was like a huge load. So this is easy to add any server, and for removing it works exactly the same way that I explained for the ring architecture. So that's how actually a consistent hashing works. So over here we can see like at any point of time adding a server, it's pretty easy. Removing a server, whenever we are removing a server, as we have multiple virtual points defined, so the entire traffic for that server is not going to one server, but it's getting distributed to multiple servers. So in that way like load is getting distributed evenly. So that's why it's like not having like too much of load in one server. That's how actually the consistent hashing works. So that's all for about consistent hashing. If you see like there is anything that which I did not cover, please do comment and let me know how exactly the video was, and hope to see you in the next video. Thanks so much everyone for watching my video. Bye bye, take care.